The 30th of November.
It is the 30th in here. This will be our very first test on our next term that is here, and actually today we are just starting off as our next term. So this test that we just took, we are cutting it there. Exactly. All right. What else did you notice that's interesting on this schedule? There's a project. And it's called the Burning Down the House project.
Oh, that was fun.
Have we heard of it?
Yeah.
Okay.
That one's fun. Because my friend did that. He actually set the house on fire.
Yeah, the goal actually is not to set the house on fire. We will talk a lot more about it. I believe Wednesday in here is where we'll cover really what that Burning Down the House project is. But you will be able to work with a partner or by yourself. So you just want to kind of start thinking about it. And again, don't stress. We will have class time to work on it. So this isn't like a whole outside of school project. Okay. Alright, so wait, so what was our very first unit in this class? Again, okay, sig figs, measurement. What was unit 2?
I don't.
Chemistry.
Chemistry.
Wait, about what? Atoms, and how to use the periodic table. Unit 3 in here then is we took those atoms and did what with them? We stuck them together, made compounds, ionic and covalent compounds. And then we reacted those things together. And what are the 5 types of reactions we got? Double replacement, synthesis, decomposition, and combustion. Perfect. Okay. And last unit, I feel like we got a little bit away from the actual chemistry piece of like the magic of these things, and we just got into like how we know how much we're actually working with. And what was that called? Stoichiometry. Are we done with that? No, because now we can do stoichiometry with a whole lot of other cool things that we will talk about. And to get us really into this unit, we will focus on a lot about gases this unit because they have their own kind of chemical behavior that we'll talk about. And just from last unit, you guys, 1 mole of any gas takes up how much space at STP?
22.4 liters.
22.4 liters. There's a reason for that, but it doesn't matter which gas it is that we're talking about. And that's really where we're going to get into this unit. But I thought in order just to talk about what gases are, how they behave, we should do what we probably did in 2nd grade. I know this is what my daughter's doing in 2nd grade, is actually talk about what the difference is between solids, liquids, and gases. And they all kind of come down to one vocabulary word, why these molecules and compounds behave the way that they do. And the word I would like you to write down is what is called an intermolecular. Probably. I was like, word? Okay. Again, I don't have an initial PowerPoint made up. This is unit 5.
That answer really shows it.
That is not one of the words that I said. I think so.
That's not bad.
You are going to go to a lab by yourself. Read us out Read labs by yourself.
Oh my God.
It's my favorite 2 days of the year. No, I get to. Oh, dang it. My partner. No, but I'll watch. It's my favorite 2 days of the entire semester. All right. Have we written this word down?
Yeah.
Okay, write it and then turn to the person next to you and say it in the nerdiest possible voice you can. Intermolecular forces. It is the force of attraction between molecules. Wait. let's compare that. Let's compare that, the force of attraction between molecules, to what's called an intramolecular force. With the person next to you, what would be the difference?
Inters between inters.
Okay, here's a question for you. If you are competing in an intramural league, are you competing with other schools?
No.
Okay, what does intramural mean?
Within
Within it. So what would an intramolecular force be? Within the molecule. So let's write that. It is the force of attraction. Oh yeah, I'll show you a picture. Yeah. Kind of zero. Force of attraction within a molecule. Okay, with the person next to you, I got one more question for you. Which one of these would ionic and covalent be? An intermolecular force or an intramolecular force? Yeah, you know.
What's the covalent?
Don't give me that. Don't like teaching regular lies. I had somebody last year, the day of the final, come in and say, "Yeah, I just don't really get this whole like atom thing." And I was like, "Wait, what do you mean, like chemistry?" And they're like, "Yeah." And I was like, "Well, do you have a question?" And they're like, "Yeah, I just don't get that." It's like, "Oh, this is gonna go really great." I don't remember. It was just, I think I like cried a little on the inside. With that. Ionic and covalent, you guys, we have talked about it as a type of bonding. Would that be an intermolecular force or an intramolecular force? Intra, because it is the bonding within the molecule, so it gets those atoms essentially to stick together, to traction between them. And then, do you remember how that unit, we talked about how bonding is really a spectrum? Yeah. We've got truly covalent things here, and then we've got our ionic things. And what do we call the things that fit in the middle? Polar covalent. Which ones share electrons, ionic or covalent? Covalent, okay. Which ones essentially steal? Which ones will have a charge, positive and negative? And ionic will. Do polar covalent, though, have a slight charge? Yes. Okay, so I need you to think of that idea. I'm going to put out 3 different substances for you. And I just, actually, these are really small, so I don't think we'll be able to see it. I have, this is from my water softener this morning. This is sodium and potassium fluoride. Okay. I have here, this is solid dihydrogen monoxide.
Oh, wow.
Okay, what's dihydrogen monoxide again? Water. Okay, I've got one more solid. Yeah, it's just ice. It is just ice, that's what's solid.
Hey, John.
Okay, hold on.
Can I play with them?
Okay.
It's like a negative 1.
Oh,
Okay. Okay. Oh, we'll talk about it. There's gas that's being formed. We'll talk way more about this. We'll see it. So just hold on. Okay, here's my question for you. Which one of these can only exist in solid? Okay. Why is that again?
Crystalline structure.
Wait, what?
Intermolecular.
What about them?
They're like strong.
Okay. So I want you to picture, do you remember when we draw sodium chloride? We've got our plus, we've got our minus. Do you remember how we talked about how this acts kind of like a magnet? Can you ever have just one sodium chloride molecule by itself? Why not? We've got that strong separation of charge and other things end up being attracted to it. So sodium chloride, because of that, is that more likely to be a solid, a liquid, or a gas? More likely to be a solid. I've got up here, again, sodium chloride, I've got water, and I've got dry ice that is here. Can you guys place these on the spectrum based off of their intermolecular forces? Which one likes to be a solid? Which one is changing? Which one is, they're all changing, or actually both, two of them are changing right now. Place it on that spectrum with the person next to you. Okay, so wait a second. Just based off of what these three things are kind of doing in front of you, is the sodium chloride changing at all? Okay, so sodium chloride, we know that it's ionic, but does it have really strong or really weak intermolecular forces, attractions to other molecules? Strong, that's why that it's a solid, that's why it's staying all together like this. What about water? What's happening to it? It's melting. It's going through a phase change, and that phase change is it's melting. So if I compare that to the salt, the attraction of those water molecules to other things, keeping it really rigid, is that very strong? No. Now, if you don't know dry ice, I like to bring it in just because I feel like you can't leave high school chemistry without actually seeing this stuff. Do you guys know what is dry ice made out of?
CO2.
It's CO2. Breathe out. That's what it is. Is your breath. Is it melting? Is it turning into a liquid in front of you? Pick it up with my shirt up here. Okay. What's it turning into? A gas. We've got a vocab word for what it's doing. Sublimating or sublimation or going, it's subliming. That's the way to say that.
Can you not hold it with your own?
It's really cold. You just can't hold it in like one spot for a long period of time. Alright, yeah, so I'm gonna do that. Okay, so what I want you to picture is we've got carbon dioxide. Right now it is stuck together in a solid here, but do you see how those carbon dioxide molecules are leaving very easily? Does it have really strong or really weak intermolecular forces? Super weak. It's got a weak attraction to other carbon dioxide molecules, so it's not staying stuck together as nicely as the sodium chloride is. Which one falls in the middle, just on the spectrum for us? Water does. It is attracted, just not as strongly as the sodium chloride molecules are. I'm going to set this guy right back down here. So we are going to use this idea of this attraction between these molecules and what makes things stick together and how well they stick together to kind of explain to us the differences between solids, liquids, and gases. Second grade, I know this is what my daughter is doing right now in her class, which is, I think, when you guys first started talking about it. I have a little simulation. In your notes, we'll wrap this up. Solid, liquid, gases. With the person next to you, I want you to describe these. What's the same between them? What's different between them?
They all.
Molecules like